Hello, my name is Pramit. I am a product manager for DX Operational Intelligence by Broadcom. This video introduces DX Operational Intelligence capability to ingest data from external monitoring tools. In this video, we will talk about the utility that enables this data ingestion, which is RESTMon, and what does it offer. Let's first understand why RESTMon. DX Operational Intelligence provides full stack observability to IT teams and enables them to make faster and smarter decisions that lead to an improved IT service quality, which in turn leads to an enhanced end user experience. DX Operational Intelligence is built on an open, powerful platform which provides users with comprehensive insights by ingesting and analyzing a diverse data set like metrics, inventory, topology, text, events, etc., from both Broadcom and non-Broadcom products into a common data lake. For large enterprises around the globe, some of the key challenges to overcome as far as IT monitoring is concerned are full stack observability view, reducing complexities introduced by new and older technologies and tools coexisting together, digitization, tool sprawl, and operational silos. RESTMon helps solve these problems by providing a framework that allows its users to ingest monitoring data such as alarms, topology, and metrics from non-Broadcom monitoring tools into DXOI's unified data lake. This helps our customers gain a unified app infra network view across all their monitoring landscape, safeguards their current investments in tools and technologies, provides with flexibility for adoption of newer technologies and tools, and last but not the least, correlate data from multiple domains in OI. Next, we will go into the solution overview of RESTMon. RESTMon in short stands for REST Endpoint Monitoring, which translates to its core function, which is getting data from any REST endpoint and specifically from third-party monitoring tools or technologies and publishing to OI. As you can see, there are about 25 out-of-the-box reference integrations present today in RESTMon. Data can be ingested from these either via polling or streaming. The types of monitoring data that can be ingested are metrics, alarms, inventory, and topology. When RESTMon receives data, it parses this data, executes any custom rules if required, and transforms that into a format which is required by OI and publishes the data to OI. Once the monitoring data is available in the unified data lake, it is treated similarly to data coming from any Broadcom monitoring tool, which means that the user can use this data to create services for monitoring. The alarms from third-party sources can be viewed conveniently in one location, which is the alarm console. These alarms also participate in algorithmic clustering of similar issues and noise reduction in form of situations. The metrics from third-party sources can be used to create monitoring dashboards, and also you can be used for capacity planning and anomaly detection. And in the end, OI can be the single point for managing all the incidents in ITSM systems such as ServiceNow, CA Service Desk, etc. Diving in a little deeper, there are two modes of ingestion, poll and stream. Streaming integration is when the data such as alarms are sent to RESTMon at its endpoint from the tool using a mechanism such as a webhook. Streaming integrations are relatively simple and are best suited when only alarms are to be ingested. Polling. Polling integration is when the RESTMon polls third-party REST endpoints at a periodic interval. This type of integration are comparatively more complex than the streaming ones, but allow you to get a broader spectrum of data, such as topology and metrics from third-party tools, when the data source doesn't provide a direct interface for this kind of data. Now, coming to what constitutes an integration. Every integration is made up of two key building blocks, a profile, and a schema. A profile is required to specify connection and polling related parameters on which your schema is going to work. There will be one profile per monitoring tool. A profile can consist of the associated schema or schemas, polling interval, the time period, the time interval at which the polling happens, connection details of the monitoring tools, monitored group details, and proxy details. A schema contains details of the data that will be ingested. If there is a need to perform in-process calculations on the data that is being ingested, it can be specified that in the schema as well. It is possible to have multiple schemas per profile. A schemas can contain the REST URLs, parsing rules and logic for different data types such as metrics, inventory, topology, etc., and also custom calculations. Additionally, the key capability of RESTMon includes uh, running as a process or a service on Windows or Linux platforms. There is also a containerized image available that can be run on OpenShift or Kubernetes. It supports both basic and token authentication. All the communication by default is over HTTPS. The polling intervals can be defined per data type, which means you can have a different polling for the metrics and a different polling interval for alarms or topology. There is also a rich API interface to interact with the tool and automate the tasks. There is also an option to specify the rules on which your alarms can be generated by RESTMon itself. We also call that the custom alarm generation, data parsing and correlation, and also inbuilt retry mechanism, liveness and readiness. Last but not the least, a very important feature, which is for the self-monitoring via the out-of-the-box dashboards in DX Operational Intelligence. To summarize, RESTMon enables ingestion of disparate data like metrics, alarms, topology, etc., into DXOI, so that the intelligent insights and actionable information can be drawn from this data and related to the wider IT landscape. The key benefits are the single pane of glass to show and correlate data from multiple domains, reduce noise by grouping similar alarms together, and reduce the number of tickets created, use of AI/ML capabilities to achieve self-managed IT, and lastly, tool consolidation. That's all in this video. Please follow us for more in-depth videos and demos in the future. Thank you.